let's start with the concept of 3D figures, which are a prism, something like this piece of cake. Now, why is it a prism? What defines a prism? A prism has a cross-sectional area which remains the same throughout the figure. Now, this shape over here, that is the same shape at the end. Naturally, we cannot see it because we cannot see the other side. So now, first of all, let me write down that a prism has a cross-sectional area which remains same throughout. It does not change. And then this prism has a height, or we can use the term length also. Now, if this chocolate cake is there, this is the height, and this area over here, that is the cross-sectional area. Now, let's try out some questions from paper 1. Another diagram is there for us. This is a triangular prism. This pink triangle, the yellow triangle, and the blue triangle, that just shows the shift, that this shape is traveling throughout the constant cross-section and it's reaching the very end. Now, if I'm talking about this shape, which is a triangular prism, now a triangular prism has how many faces? Let's have a look. There is the side wall, that is this one. There is the floor over here. There is the front. There is the end. And then there is a sloping face. So there are 5 faces over here. Let me write it down. There is a wall on the side wall. There is a floor or the bottom. There is the front and there is the end. These two are exactly the same because it has a constant common cross-section, and then there is a sloping face. Now, if I write further, the side wall is a rectangle. The floor and the bottom, that's a rectangle. The sloping face is again a rectangle. And what about the front and the end? They are triangles. So if I'm talking about the total surface area of any prism, in this case, it's a triangular prism. So total surface area is sum of areas of all the faces. So basically, this is 2D mensuration. We would apply the formula for a rectangle, another rectangle, another rectangle. Yes, the dimensions will be different. The front and the back end, that is this triangle over here. We will add it all up and we will get the total surface area. Now, if I talk about the volume of any prism, so volume of prism, the formula is straightforward. That is cross-sectional area multiplying with the height or multiplying with the length. So cross-sectional area, we multiply it with the length or the height. Now, it's a matter of perspective. If we are seeing it like this and it's lying down, therefore, this is the length over here. So this is the length over here. It's starting from here, going all the way till the end. And then this one is the cross-sectional area. And that's how we get the volume. Another diagram that we see. What is this? This is a cylinder. For our purposes, we will call it a prism. We will call it a circular prism. But in reality, prism has straight edges. So there is a circular edge over here. Let's just call it a circular prism, which is popularly known as a cylinder. Now, if I talk about this this is the top, and then this is the bottom, and then this we have already studied, the curved surface area. And we can add up all the areas. The top has an area of pi r square, that's a circle. Bottom has an area of pi r square. Curved surface area is 2 pi r h. Therefore, the total surface area is the sum of all the areas, that is 2 pi r square, because we are adding this and this, plus 2 pi r and h. What about the volume? The volume, we know the formula, but let's consider it as a prism. So that is the area of this cross section, which is a circle. So cross-sectional area multiplying with the height. So what is the cross-sectional area? Pi r square. And what is the height? H. That is how the formula pi r square h is obtained. Now let's look at this past paper question, go through it, and then I'll start the working of it. The question says, the diagram shows a solid prism of length 20 centimeter. So let me highlight few important things. And first of all, this is the length over here, that is 20. This naturally is also 20. This dotted line over here is 20. And there is 20 over here. All these sides are 20. The cross section ABCD is a trapezium. Now, what is the cross section? This is 3 over here. And then this is 3. These two lengths are 3, 3. And then this is 6 over here. And then this is 6 over here. And what else is there? This is 2 over here. This is 2 over here. So basically, I've labeled all the edges. And they have given us the different dimensions over here. This angle is 90 degrees. Calculate the area of the trapezium. Calculate the total surface area. Now, first of all, what I can do is that, let me figure out how many faces are there. There is the top rectangle. There is the bottom rectangle. There is the side wall. There is a front and a back trapezium. So just like the diagram that we got started with, the triangular prism, this is a trapezium prism, if that name sounds okay. So now, first of all, let me draw some lines. Let me make some thicker lines. So this is like 2, and then this is like 3. So 1, 2, 3 like this. And then the green line is like 6. So 1, 2, 3, 4, 5, and 6. And let me choose another color. I think I've chosen almost everything. Let me choose something dark, which is like this. So I've chosen this. That's almost the same as this. So let me choose orangish. So this is the orange color over here. And this is the orange color over here. So therefore, let me draw it like this. Now, let me label the values. This is A. This is B, this is 2, this is 5, this is 3, and this is 6, and this is 90. So for part A, the area of a trapezium, that is half sum of parallel sides multiplied with height. So these two sides are parallel, 2 and 6. Let's add it up. And the height is this 3, that goes over here. So this is half into 8 into 3. This comes out to be 12 centimeter square. That's the area of the trapezium. Now, let me add part C over here. That is, calculate the volume of the prism. So let me do part C first. So volume of the prism, that is volume. That is cross-sectional area. CS stands for cross-section area multiplying with length. So cross-sectional area is 12. Multiply it with 20. That comes out to be 240 centimeter cube. I have done part C. Calculate the total area of the prism. So now, first of all, part B. Let me calculate the top rectangle. Let me calculate the bottom rectangle. let me calculate the sloping wall, the sloping rectangle. Let me calculate the front trapezium, which we have already calculated. And let me calculate the end trapezium. Let me create some more space over here. The front trapezium and then the back trapezium. So area of trapezium is 12. This is 12. This is centimeter square. This is centimeter square. The top rectangle is 2 times 20. That's 2 times 20. You can see it. That is 40 centimeters square. The bottom rectangle is 6 times 20. That is 120 centimeters square. And the sloping one, that's 5 times 20. That is 100 centimeter square. So let me add it. This is 40, this is 120, that's 160 plus 100, 260, 260 plus 24. So the total surface area is 284 centimeters square. That's the answer for this part. So that's how this basic question of prism is done. And if I'm not mistaken, this is everything that we need to do. So that is everything is in centimeters. So this is 100 and 120 and 40 and this thing. Now let's move on. Something to do with paper 2. Now let's read this question. Now, what do we see over here? This is like that cake slice. So let me just add that cake piece over here. That thing, let me just pick from here. And it goes somewhere over here. I hope so. Yes, there it is. So this is something like that. Just watch these two very closely. If I skip the strawberry, so this shape over here, it's a sector. This over here is a sector. It's that same cake piece lying down in the plate. So now let's say this angle is 40 degrees. So let me draw some lines. Let me draw some thick lines over here. So a red line over here like this. Another red line over here like this. And then let me draw this curvature over here. Now let me label this angle over here as 40 degrees. So this thing over here, this is 40 degrees. And the radius over here is 8. So therefore, this thing is 8 centimeter. This thing is 8 centimeter. It's not drawn to scale. It's just a rough diagram. And this thing over here is 20. That means if I stand it up, so therefore this thing over here, from here till here, that is 20 centimeter. Keep in mind, the diagram is not drawn to scale. This is rough, just a rough diagram. Okay, so diagram is not drawn to scale. What do we need? Calculate the area of the cross section. Now keep in mind, whenever you solve a question, since we are doing topical questions, make sure whether it's paper 1 or paper 2. This is a paper 1 question, so it's without the calculator. So now the first thing, area of cross section. So B part 1, that is area of the sector. That is theta over 360 degrees into pi r square. And over here, this is theta, which is 40. 360 is 360 into pi into r, which is 8, and this is square. So therefore, my bad, this is paper 2. So that means you can use a calculator. Otherwise, I would have left the answer in terms of pi. This is 1 over 9. This is pi, and this is 64. So let's multiply it out. Let me grab a calculator. So therefore, this is 3.142. Let's use this value into 64 divided by 9. This comes out to be 22.34. This is 22.34 centimeters square, but when I write it over here, I'll write 22.3 centimeters square, correct to 3 significant figure. This is 4 SF value. Final answer, 3 SF. This is final answer. Okay, now it says the total surface area of the prism. Now for total surface area, what do we need? We have this wall, which is an 8 by 20 wall, a rectangular wall. The same is on the other side of the cake. And then there is the top, which is a sector. The bottom is a sector, and this is curved surface area multiplied by length. So now there are 5 faces. There are 5 faces of this trapezium. The top is a sector. The bottom is naturally the same sector. This is the common cross section. Let me first write it down. Then there are 2 walls, rectangular walls. One wall left, let's call it left, and let's call it right. And then what do we have? We have this thing, which I've drawn over here. Let me draw it again. A red marker that goes like this, and hold for a second. It goes like this, and let me make it straight, like this, and like this, something like a 40-degree thing. And then this blue line, which is the curvature like this. So let me make it better all the way over here. So, and let me just remove any extra things over here. Precision 1. So let me remove this, and let me remove this. Okay. Now this is 8 centimeter. This is 8 centimeter. This is 40 degrees. This is the arc length. Now this arc length I can calculate. So S is equals to 40 over 360 degrees into 2 pi r, because it's part of the circumference. So therefore, this is 1 over 9 into 2 pi into 8. So first of all, let me write this thing as 16 over 9 pi. That's this. Now, basically what we are doing is that if I multiply this 8 by 20, I can just take this length and multiply it with 20. So I'll get that particular curved surface area. That is just like part of the curved surface area 2 pi r h. Basically, it's the same thing. So therefore, the curved surface area, that is 16 over 9 pi, that is the arc length multiplied by the height, which is 20. So therefore, let's multiply it out. That is 320 over 9 pi centimeters square. What about the left wall and the right wall? That is 8 into 20. That is 8 into 20. This is 160. This is 160. We will write the units at the end. What about this thing? That is 64 over 9 pi. So the top area is 64 over 9 pi. The bottom area is 64 over 9 pi. Now let's add it all up. 1, 2, 3, 4, and this one, that's 5. So therefore, let me draw a box. The total surface area is the area of all these 4 faces, 5 faces actually. That is 2 times the sector, that is 64 over 9 pi. That's 2 times 160. And then we have this thing, the curved surface area, that is 320 over 9 pi. So let me write this thing, that is 128 over 9 pi. And this is 320 over 9 pi. And this is 320 from here. Okay, so this is 128 plus 320, 128 plus 320, that is 448 divided by 9. So that's 448 over 9 pi plus 320. Now let me plug in the value, 448 over 9 into 3.142 plus 320. So multiply it with 3.142 and add to it 320. So therefore, this comes out to be 4 476.40. Let me give the answer as 476, not 474. This is 476. So let me correct it. That is 476.40. So the answer is 476 centimeters square. That is the final answer, correct to 3SF. So now let me go ahead and check this answer. This is question number 2. And this is question number 2. That is it. This is 476 to 477. Depending upon the rounding off, they are accepting both the answers as correct. Now, another question similar to this. Just have a look at this question. This is again a paper 2 question. It's just like the cake one, except for the fact that this is a quarter circle over here. Let's see how many parts there is. We're just focusing on the first part. Diagram 1 shows a vessel in the shape of a prism. So this is a vessel in the shape of a prism. This is the cross section. The cross section is a sector of a circle, radius 8 and angle 90 degrees. So it has the same radius as the last time, except for the fact that the angle is 90 degrees, except in the previous one, it was how much? It was 40 degrees. Now, let me just draw this over here. Okay, so that's how this prism is drawn. Calculate the perimeter of the sector OAB. So let me draw this line over here, which is, let me draw it over here. Draw it a bit bigger and blue color. Okay, so just to give you the idea, this is O and this is A, this is B, this is 90, this is 8 centimeter, this is 8 centimeter, this is 90 is already drawn. So therefore, arc length AB, I can write this thing as 90 over 360. That's 1/4 because it's a quarter circle into 2 pi r. It's part of the circumference. The value of r is 8. So let's simplify. 90 ones are, 90 fours are, and then 4 ones are, 4 twos are. So 2 into 2, that comes out to be 4 pi. That is the arc length. So therefore, perimeter of this sector OAB, that is radius plus arc length AB. Radius is 8, arc length is 4 pi. That is 16 plus 4 pi. I can convert it into decimals. So that would be, I'm not using the calculator for right now, 16 plus 4 times 3.142, and just worry about the calculator later. Focus on the concept over here. Now it says the vessel which stands on horizontal table contains 8,000 centimeter cube of water. That is the volume of this water. Calculate the depth of water in the vessel. That means volume of water, A part 2. So now I'm working on part 2. And that was part 1. So this was A part 1. So volume of water in the vessel, that's the volume of the prism. That is cross-sectional area multiplied with the height. The volume is 800. Cross-sectional area is 16 plus 4 pi. 16 plus 4 times 3.142. And then multiplying it with h. So I can make h the subject. That is 800 divided by 16 plus 4 into 3.142. Now at this point, I'll use a calculator. And I'm adding 16. So therefore, I have 28 point something, and then I'm multiplying 800 divided by this value. So this comes out to be, I think, the same value approximately. H comes out to be 28.00. Therefore, the final answer is 28.0, correct to 3 significant figures. So this is question number 9. And I don't have the answer for question number 9. And it looks that this is the answer. So that completes the concept of prism.